All right, I will be going over some questions that might be helpful for you. Question number one is, we found a relationship between mass and weight in class the last time, and this is last time is the first class for mechanics, which is unit 2. Write down the equation that relates mass to weight. So if you remember, I'm going to give you an example of 1 penny. 1 penny, the weight in newtons, you should have gotten something like 0.2 n, and mass in kilograms something close to 0.02. Okay. Now, in order to get a relation between these quantities, a very nice thing that you can do is to divide them. So if you divide W by M, you get 10, close to 10. Now this factor is also called G, which is acceleration due to gravity. And if someone just says G or acceleration due to gravity, they really mean acceleration due to gravity on Earth. Okay? Acceleration due to gravity can differ on different planets. But for Earth, this value is 10. So if someone asks you if the mass is m, what is the weight in newtons? You just multiply that number by 10. Just to recheck, in order to get W in newtons, if you have mass in kilograms, which is 0.02, you multiply that by 10, you get 0.2 newtons. So it checks out. And we now have an equation that is W equals to mg, where small g is 10 newtons, not newtons. If you're interested, the unit is actually meter per second square, but that might be not important for you just now. But if you multiply that factor 10 by mass in kilograms, you get weight in newtons. Question 2 is, how much will an object of mass 0.25 kilograms weigh in newtons? Again, we're going to use the formula W equals to m times g, and m is given to be 0.25 kilograms. So I'm just going to write the given quantities. M equals to 0.25 kilograms and G is equal to 10. By the way, so if I'm imagining if you're watching this video, you have this question in front of you. A really healthy way to learn these things is to, let's say, pause the video right now and look at the problem, right? And try to solve the problem yourself. Take like 5 minutes, maybe 10 minutes, not more than that. Look up, try to understand what is being asked, how much do you understand it, and try to solve it. And as soon as you give up, and as soon as it has been too long and you should have solved it by that, you can replay the video, you can play the video and see me actually solving it. So that way you will um, get into a like shape for exams and to really understanding these things because you will get into a place where you will try to find these things. So basically, it's like it's a big puzzle, and then there are small puzzle pieces. You have to understand how those puzzle pieces fit. And a very good way to understand that is to first try to solve yourself, and if you give up, then it's fine. Just look at the solution, right? But if you just watch me do it, then you will probably not understand it. It's like riding a bike. Remember, like, try to recall, how did you learn to ride a bike? You get on it, right? And you try, and then you fail, you get bruised a couple of times. It's okay, you get up and you try again, right? But I know for sure if you watch a YouTube video on how to ride a bike, if you read a book on how to ride a bike, or if you watch someone else riding a bike, you will never figure out how to ride the bike yourself. So you really need to be on the seat in order to ride the bike. So this is very much the same. You really need to do it to understand it. Okay. So we have the given quantities as mass to be equals to 0.25 kilograms, g equals to 10. To get the weight in newtons, all you need to do is just multiply m times g, and that is 0.25 times 10, and that is equal to 0, no, that is equal to 2.5 newtons. That is the answer. Okay. Question 3 is the opposite of that. It says, what is the mass of an object that weighs 28 newtons? Okay, so we are given the weight and we need to find the mass. So you use W equals mg. W is 28, m is what we need, and g is 10. Dividing both sides by 10, you get 28 over 10 equals to m, and that gives you mass to be equal to 2.8 kilograms. Question 3 is, what is the volume of a cube with length equals to width equals to height equals to 2.5 centimeters, right? So volume of a cube, let's make a cube. And often it really helps if you make diagrams. So a cube is something like that, right? The length is 2.5 centimeter. The width is 2.5 centimeter, and height is also 2.5 centimeter. Okay, like the formula for volume of a cube is length time width time height, right? So if you have that, then the answer is it is 2.5 centimeter times 2.5 centimeters times 2.5 centimeters. I'll need a calculator for this, which I don't have laying around, so I'm going to use my phone. So what we have here is 2.5 times 2.5 times 2.5 centimeter times centimeter times centimeters. So 2.5 times 2.5 times 2.5 is equal to 15.625, and centimeters times centimeters times centimeter is centimeter cubed, or centimeter to the power 3. So the answer is the volume of the cube is 15.625 centimeter cube. Question 5 is, Jessica bought a tall flower vase for some flowers she brought from Kroger. The length and width of the flower vase are 10 centimeters and 15 centimeters respectively. When she got home, she poured water of volume 3000 centimeter cube. How high is the water in the vase? This is very similar to the yellow sheet question number 1 from first class of mechanics. Okay, so if you have done that, then you should be able to do this. If you have not done that, then maybe this will help. So, um, so we have a vase, and the length and width are given to be 10 centimeters times 15 centimeter. Okay, so vase like that. Because the length and width are given, it is safe to assume like it is something squarish, right? It is not really a vase like that. Something squarish, like a very boring vase. But anyway, so the length and width are given to be 10 centimeter, and width is 15 centimeter. When she got home, she poured the water of volume 3000 centimeter cube. Okay, so this is an empty vase. Let's put some water in it. So I'm putting some water in it. That's the water line, and that's the water in it, right? So whatever volume that is, the height is given. Oh, sorry, the height is not given. That's what we need to find. but the volume is given, right? So let me write down the given quantity so that everything is very clear what I'm given and what I'm supposed to find. Quantity, not quality. Length 10 centimeters, width 15 centimeters, and volume 3000 centimeters. So when we need to find height, okay, so we will use the formula again. So what I'm trying to do here is I'm only looking at this, right? Because if you look at this, this makes a cube, okay? Only the I'm only considering a cube of width 15 centimeter, length 10 centimeters, and height. We will find how much that height is. We're just calling that h for now. But I'm only looking at this guy, right? This piece. This, imagine I can just take out the water like that. Imagine this water freezes and I can take out that cube. So I'm looking at that cube, right? So the volume is the volume of that cube. The volume is the volume of water which corresponds to that cube. So the formula that we know is volume is equal to length times breadth times height. The volume is given to us, that is 3000 centimeter cube. Length is given to be 10 centimeters. Width is given to be 15 centimeters. And height is something we need to find. So if I divide both sides by 10 and by 15, I will have height is equal to 3000 divided by 10 and 15. And there are 3 centimeters here, like centimeters times centimeters times centimeter. And there are 2 centimeters here. So what I will have on the left hand side is the centimeter, and which should be the case because we are trying to find how high it is, right? Centimeter is a unit of length. So it makes sense on the left hand side you just have 1 centimeter remaining. So you just do this calculation. You do 3000 divided by 10 divided by 15. And the answer is the height should be 20 centimeters. So in question number 4, we saw very simple, um, very simple utilization of the formula. Volume of the cube is equal to length times width times height. And sometimes when I say cube, I don't really mean that all the dimensions are equal. Technically, that is the case. So when that is the case, I mean, the formula stays the same. It is length times width times height. Okay. And here it is not exactly the cube because the length, width, and height are different. But let me just call it cube for a second. But anything that is a square and has like that is anything that is boxy has volume, length times width times height. So now here we use the formula that we learned how to use directly in question 4 in a more indirect way, where instead of finding the volume, we were given the volume and we had to find the height. Okay, now you can imagine a question where the volume was given and the height was given, and let's say the length was given, but um, I wrote B for breadth, should be W, doesn't really matter, but just for the sake of completeness. So I was saying like this formula has 4 things in it, right? So often you might be given 3 things and you're supposed to find the 4th thing. Um, Often you're just given 2 things, but you know the 3rd thing. So the idea is like in order to use this formula, you need to know 3 things out of 4 things. That's it. Question number B for part number B for question 5 is what is the mass in kilograms of water in the vase? Okay, what is the mass in kilograms of water in the vase? So this is about using the formula density equals to mass over volume. Okay, so I can know the mass if I know the volume and if I know the density. Okay, I know the volume. Volume is 3000 centimeter cube. That's given, right? And I know the density. So density of water is standard. Density of water, let's say D sub W is 1000 kilogram per meter cube. Okay, so if you have a box of water that is 1 meter cross 1 meter cross 1 meter, that will weigh 1000 kilograms. 1000 kilograms is really heavy, and 1 meter is about this much. So make you can make sense like like how, how much that weighs, what that thing is intuitively. Um, so we're gonna use this formula where density is equal to mass over volume, right? Volume is given to us, and that is equal to 3000 centimeter cube. I'll do this two ways. I will first convert this volume from centimeter cube to meter cube because meter cube is the international system of units. And we really need to understand, like really need to feel comfortable with this system of units, okay? So I will convert the volume into meter cube, and then I will use the formula for density, where density is 1000 kilograms per meter cube. This is going to be a little more complicated than if I do not convert the volume to meter cube, but I use the density for water to be 1 gram per centimeter cube. Okay, so let me do the hard thing first. Okay, let me just make a division here. So maybe I should do something like this. Okay, hard way. Centimeter cube to meter cube. That's the hard way. So as I said, step one, convert that centimeter cube to meter cube because eventually I would like to use the density equals to mass over volume formula using the density that is in kilogram per meter cube. And also because we need to understand, we need to find ourselves being comfortable with the international system of units. So the conversion, like if you understand this, this will be really helpful, okay? So conversion is that I'll derive the conversion, right? So 1 centimeter, maybe I should do this someplace else so it was more clear. Okay, let me just go all the way down here. Let's do that. So converting centimeter cube to meter cube, right? This is how you do it. And this is something, if you do it a couple of times, you will know how to do it. You don't have to do this whole like one page of algebra again and again every time you need to convert from centimeter cube to meter cube. So 1 centimeter is equal to 1 over 100 meters. So 1 over 100, like one part out of 100 parts of a meter is 1 centimeter, right? 1 centimeter cube is just 1 centimeter times 1 centimeter times 1 centimeter. So that means this is equal to 1 over 100 times 1 over 100 times 1 over 100 centimeter cube. Oop. Oh, not centimeter cube, meter cube. Because 1 centimeter is 1 over 100 meter, 1 over 100 meter, 1 over 100 meter. So you've got meter times meter times meter. So you've got meter cube. So that tells you that 1 centimeter cube is equal to 1 over 100 times 100 times 100 is going to be 1 with 6 zeros after that. 1, 2, 3, 4, 5, 6 centimeter cube. In scientific notation, this is also written as 1 centimeter cube is equal to 10 to the minus 6 centimeter. I keep saying centimeter cube on the right side as well. It is meter cube. That's the whole point, isn't it? Is meter cube. Okay, so we now know that 1 centimeter cube is 10 to the minus 6 meter cube, or 1 centimeter cube is equals to 1 over 1 followed by 6 zeros meter cube. Let's go back to the problem that we're trying to solve. All right, so 1 centimeter cube is equals to 1 over 100 0.0000 meter cube. Okay, so that is 1 centimeter cube. And the volume we have that we want to convert to meter cube is 3000. That's the volume we have, right? That we need to convert to meter cube. So if 1 centimeter cube is 1 over 1,000,000,000 meter cube, 3000 centimeter cube will be 3000 divided by 1, 1, 2, 3, 4, 5, 6 meter cube. So that will be equal to 3 over, it's getting really cramped here. That will be equal to 0.003 meter cube. So now we have the volume in meter cube. So I'm use the formula density is equals to mass over volume, and this means that this is equal to same as mass equals to density times volume, right? Because this is helpful. So if density is equals to mass over volume, then mass equals to density times volume, and volume is, so the mass is equal to density, which is 1000, very standard, kilogram per meter cube, times volume, which is 0.003 meter cube. So meter cube cancel. You divide meter cube by meter cube, you don't have anything remaining except 1. So the mass is 1000 times 0.003. Okay. So that is equal to 3 kilograms. That's the answer. So the mass is 3 kilograms in the vase. The mass of the water is 3 kilograms in the vase. The second way is to use the density to be 1 gram per centimeter cube, this number, and not convert centimeter cube to meter cube. Okay, so the idea is this, but eventually we'll have to convert gram to kilogram. You'll see that, but it is an easy conversion as compared to centimeter cube to meter cube. So because the volume is already given in centimeter cube, I can use the density, which is also in terms of centimeter cube, to find the mass in grams. And once I have the mass in grams, I can convert that mass to mass in kilograms. So that's the other way, right? That's the easy way. It is easy way because we're definitely not doing centimeter cube to meter cube, but we're going to choose gram to kilograms, which is easier, and you'll see why that is easier. So centimeter, not converting centimeter cube meter cube. Okay, so the volume is given to be 3000 centimeter cube. So density is again mass over volume. Density is 1 gram per centimeter cube. So you see, like, the difference is that this time I'm using 1 gram per centimeter cube instead of 1000 kilograms per meter cube. The reason is that the density is already given in cubic centimeter or centimeter cube. So I'm just going to use this density. The volume is already given into centimeter cube. So I can use just this formula of density, which is also in terms of centimeter cube, right? So that will be equal to mass, which we need to find, divided by volume, which is 3000 centimeter cube. If you multiply both sides by 3000, you will get 3000 centimeter cube times grams times centimeter cube is equals to mass. And centimeter cube and centimeter cube cancel. It's like dividing 2 by 2 or 100 by 100, same as dividing centimeter cube by centimeter cube. and that gives you mass to be equal to 3000 grams. Okay, you just have that 1 gram hanging, so the mass is in grams. But look at the problem. It says, what is the mass in kilograms? So we need to convert. That's what I was talking about. Instead of converting centimeter to meter cube, we're going to convert grams to kilograms. But it is easier because this time the conversion is pretty easy. If you have 1 gram, that is equal to 1 over 1000 kilograms. So if you have 3000 grams, that is equal to 3000 times 1 over 1000 kilogram, and that is equal to 3 kilograms. So it checks out both ways. Doing this way, which was the hard way, was the answer was 3 grams and 3 kilograms, and then again did the easy way, and the answer was again 3 kilograms. Okay, so I would say do not rely on only one way. Please understand how to do both the ways, because it is also really important to understand how to convert centimeter cube to meter cube. And now the easiest question of all, easiest question of question, easiest sub part of question 5, which is what is the weight in water? Well, the weight in water is pretty easy. It's the m times g, right? Remember? So weight of water in newtons is going to be 3 times 10, and that is 30 newtons. Okay. The next part here is some conversions in it's a little late for conversion like this and this, right? I already told you. But just to convert like some distance units and time units, 1 mile is about 1609 meters. Okay, meters is the unit that internationally is used outside of the US. I think pretty much every country outside of the US uses meters. And if you have 1609 of those meters, that corresponds to 1 mile. If you're interested, because 1000 kilometers is about 1000 meters is about 1 kilometers. This is same as 1.609 kilometers. So 1 mile is equal to 1.069 kilometers. All right, anyway, question 6 is convert 40 miles per hour into meters per second. Okay, so we'll need this as well. 1 hour is equal to 3600 seconds. You get that number because 1 hour has 60 minutes and each minute has 60 seconds. So that is equal to 3600 seconds. So that's why 1 hour is equal to 3600 seconds. All right, the conversion that we need to do is 40 miles per hour to meters per second. Okay, so 40 miles per hour. So this is the unit of speed. So speed given by v, because sometimes there's also a variation of speed called velocity. But most of the time you can use them interchangeably. But anyway, so speed is 40 miles per hour. Okay, and we need to convert this number into meters per second. All right, well, let's do it. So 40 miles per hour. 1 mile is 1609 meters. 1 mile is equals to 1609 meters. And 1 hour is equals to 3600 seconds. So that means you just do 40, 1 mile is 16909 meters. So it is 1609 meters. And 1 hour is 3600 seconds. So this means that 40 miles per hour is same as 40 times 1609 divided by 3600 meters per second. I'll use my calculator to calculate that number. 1609 divided by 3600 equals to 0.44, and that is equal to 0.44 times 40 is equals to 17.36 meter per second. 17.36 0.36 meters per second. Okay. Question 7 is convert 130 meter per second into miles per hour. Alright, so again, distance over time is speed. So you need to convert 130 meters per second into miles per hour. Okay, so I know that 1 mile is equal to 1609 meters. This means that 1 meter is equals to 1 over 1609 miles, right? And 1 hour is equals to 3600 seconds. This means that 1 second is equal to 1 over 3600 hours. So that means this is equal to 130 times meters. 1 meter is 1 over 1609 miles divided by 1 second is 1 over 3600 hours. So we'll just use the calculator here. So 1 over 0.09 is really tiny number. And this is about 130 times this fraction 0.00625 divided by 0.000277 is about 2.24, and this gives you 291.2 miles per hour. Okay, I got I had a little bit of think there. 130 meters per second. I just thought it will be a smaller number, but looks like one. We're gonna trust the math here. 130 meters per second is 291.2 miles per hour, which kind of makes sense because when it was 40 miles per hour, it was about 17.36 meters per second. So if it is 130 meters per second, it can be about 291 miles per hour. So I think we are good there. All right, convert 1,000 centimeter cube into meter cube. Convert 1,000 centimeter cube into meter cube. Oh, well, all right, so we have done this conversion. A centimeter cube is equal to 1 over 1, 1, 2, 3, 4, 5, 6 zeros meter cube. So 1,000 centimeter cube will be just 1,000 times that much. Okay, so 3 zeros, they take care of 3 zeros here, and 1 over 1 over 1 over 1,000 1 over 1,000 is 0.0001 meter cube. I'm just going to use my calculator just to make sure everything makes sense. Right? So that's your answer. 1,000 centimeter cube is equal to 0.0001 meter cube. Convert 30,000 grams into kilograms. Convert 30,000 grams into kilograms. Well, 1 gram is equal to 1 over 1,000 kilograms. This means that 30,000 of those will be equal to 30,000 times that number, 1 over 1000, that factor, kilograms. So that will be equal to 30 kilograms. Okay. So this is what you needed. These 9 questions uh, were needed in order to make sense of the unit conversions that were in class 7, I think, the first class of the unit mechanics.